Hello everyone. Today we're starting a new unit. This is Unit 6 and it will be our last unit of the year in quadratic relations. So what we're looking at over the next couple of weeks is quadratic equations in a little bit more depth. We have looked at all three forms, standard, factored, and vertex, and we've looked at different properties of each. And now we're going to dive a little bit more into our standard form equation, ways we can manipulate it, ways we can solve it, and we'll introduce you at one point in this unit to the famous quadratic formula. But for now, we're going to look into what we call solving quadratic equations. And we've been doing this a little bit, so we're going to have a bit of a warm-up. In our first example here, it says, given that we have the equation y equals negative 4x squared plus 10x plus 6, solve for each of the indicated y values. Okay, so in A, it says our y value of 0. All that means is we're setting this equation equal to 0, because that's where y is, and we are going to solve. When it says to solve, okay, really that means we're trying to figure out what is x when y is equal to 0. And we've done that before in unit form. What we're going to do here is we're going to factor. So let's see if you can remember your factoring skills. Take a few minutes to factor this problem, negative 4x squared plus 10x plus 6, and see what you get as your factors at the end. So if you factor it, this is what you get as a result. So we're going to take these factors that we've just come up with here, 2x minus 6 and 2x plus 1, and we are going to set them equal to 0 and figure out what our two zeros are in this case. So 2x minus 6 equals 0. If we isolate and we solve for x, we're going to get and the same thing here, isolate our x value and solve. So our first value of x is equal to 3, and our second value of x is equal to negative 1/2. When we look at this, we can verify that. So where do we see on here y equals 0? Okay, well, we know that y equals 0. I'm just going to highlight this, even though we can see the y-axis clearly, as being right here. When we do that, what do we notice? Well, what are the x values? Well, one here, that's negative 1/2, the other is 3. So we used our graph to verify. That should be a bit of a review. If we move on to this problem here, it says figure out what x is when y is 6. So again, you're going to take that equation, but instead of making it equal to 0, we're going to make that equal to 6. These steps will look similar to what you did in partial factoring. So you can recall that this is going to be similar to what we had in partial factoring, or symmetry. Okay, so take a few minutes here and go through those process that you learned in Unit 5 and see if you can partial factor this problem once you've made that equation equal to 6. So if you partial factor and you follow that process that we did, so we brought the 6 over and then we collected our like terms and we partial factored the negative 4x squared plus 10x, the result is that you get an x value of 0 and negative 5/2. So that was when y equals 6. If we go back up to our graph here, and we see that line of y equals 6, which is right there, what are your y values, or what are your x values? Well, one is x equals 0, and that corresponds with what we just did. And the other is about 2.5, or 5/2. So our graph helped us verify that as well. So we set an equation equal to 6, and we verified that our x values when y is equal to 6 are 0 and 5/2. Let's take it a step further, and this is where things start to get a little new. So we have y equals negative 8. What we're going to do here is, again, we're going to make that equation equal to negative 8, which is negative 4x squared plus 10x plus 6. Now this is a little different than partial factoring, but the same process. We're going to want to bring this negative 8 over, therefore making one side equal to 0. Opposite operations tell us that that now is plus 8. And if we combine our like terms, we're left with a trinomial or a quadratic negative 4x squared plus 10x plus 14. Now we're still expected to solve the equation for when y is equal to negative 8. So the way we have to solve this equation is by factoring. So we're going to set up our t-chart. We're looking at values that multiply to negative 56 and add to positive 10. See if you can come up with those factors and also at the same time factor this entire quadratic here. Take a few minutes now and then check your answer in a second. If you factor that equation, you should get the result of negative 4x minus 14 x plus 1. Here we want to again solve for both our values of x. If we were to set each of those factors equal to 0, our first value of x will be equal to 14 over 4, and our second will be negative 1. Now let's go up to our graph again and verify that this is correct. So if we find on here where y is equal to negative 8, it would be this line right here. And what are those two values on our parabola when we cross? Well, this one right here would be x is equal to negative 1, and this value right here is about 3.5, which is equivalent to our other value of 14 over 4. So you can take any value of y and solve for x by plugging it in and bringing it over to the same side as the equation, combining like terms, and factoring. And that is essentially how you can solve a quadratic equation given a specific y value. You saw that we have already done it in our course for y equals 0 when we were factoring. This example here was very similar to partial factoring, and that was you essentially setting it equal to whatever that c value was. And then you also have any other value, and we use the example of y equals negative 8. We set our equation equal to negative 8 and we solved. So here are the steps to kind of solving quadratic equations. First, you're going to rearrange the equation such that 0 is on one side of the equation. So you plug in that value of y, for example negative 8, and then you're going to rearrange the equation so 0 is on one side and all of your constants and variables are on the other. This equation that results from that, once you've done that, is an equivalent equation. So if we go back up and we look at this, our equivalent equation is right here. Negative 4x squared plus 10x plus 14. That is an equivalent equation to the equation that was given to us in the question, which is negative 4x squared plus 10x plus 6. Okay, and then we are going to solve for x by factoring the equivalent equation. We're going to set each of those factors equal to 0, and we're going to solve those equations. And that means just get our x values like we did here, x1 and x2. Sometimes, as you're going to see in the next couple examples, that some of the equations involve expanding or a little bit more rearranging, and it's important just to take your time in this process and make sure that you have the right signs in front of each of your constants, because one small error can lead to the entire problem being wrong. So let's go through a couple examples again doing that. So simplify and then solve each equation. So simplify, referring to the fact that we need to set one side of our equation equal to 0 and all of our values on the other. So if I want one side to be equal to 0, it means I'm going to have to bring 6x plus 10 over here. 4x squared is there, 6x is now negative 6x, and 10 is also negative 10. We've rearranged so that we have one side of the equation equal to 0, and now what we need to do is solve or factor this. So we're looking at values that multiply to negative 40 and add to negative 6. So if you factor that equation and you use the factors of negative 10 and 4, the result is that x1 is equal to 10 over 4, x2 is equal to negative 1. So if you were to simplify and solve that equation, your two solutions of solving that quadratic equation are 10 over 4 and negative 1. That one had just a simple rearrange step. If we continue, we look at a much more complicated problem that involves some expanding and some rearranging. So I'd recommend just expanding those things first and then getting into rearranging. That being that we're going to use distributive property here, 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 and here. So let's do that now. 2x times x, it's 2x squared. 2x times 4, that is 8x. And we still have the minus 12. Negative x times x is negative x squared. Negative x times 1 is simply negative x. Now we want to bring everything to one side of our equal sign. So let's do that. And we want to make sure that one side of our equal sign is equal to 0. So I'm going to make the left side equal to 0 and bring everything to the right side just to be consistent, which means I'm going to have negative 2x squared, I'm going to have negative 8x, and I'm going to have positive 12. All we have to do is combine our like terms now. Okay, so we have an x squared term here and here. We have an x term and an x term, and then we also have one constant of 12. So combine those like terms. What do we get? Well, that would be negative 3x squared. Okay, negative x minus 8x, that's negative 9x. And then we also have our plus 12 at the end. And that's our resulting equation. So now that we have everything expanded, rearranged, and we're asked to solve, again, this is what we're factoring. We're factoring negative 3x squared minus 9x plus 12. Set up your t-chart. Well, negative 3 times 12, that's negative 36. So we're looking at values that multiply to negative 36, and they add to negative 9. Go ahead and see if you can take a few minutes, come up with those factors, and try and identify what the solutions are at the end of this problem after you factored it. So if you go ahead and you factor that problem, and you use those factors of negative 12 and 3, you're going to go through, and your solutions when you finish this problem are x1 is equal to 1, and x2 would be equal to a negative 4. So this is just one further step that we've added today that we've been doing already. So you are factoring, but now before factoring, sometimes you won't have a rearranged equation. You're going to have to expand, you're going to have to simplify, collect like terms, and then go about your factoring. Okay. Just a few questions from today's note, looking at page 320 to 321, number 6, 7, and 13. Attempt those, go through the video one or two more times, and if you have any questions, let us know. Awesome.